Hi, I'm a senior dev, and this year I've been building software faster than ever using AI. I'm going to talk about the impact that AI has had on my development process, and then take a look at context, which I think is an important part of integrating LLMs successfully into your workflow. After that, I'll show you how I decide which models to use and which models I'm currently using. And finally, we'll take a look at various techniques to use when working with LLMs to get better outcomes. I love programming, and so I was reluctant to adopt LLMs into my workflow because they seem so disruptive. I was also very wary of the hype. But now that I've been working with this technology for a while, it's clear that the gains are impossible to ignore. It's not only about moving faster, but also about the mental effort required to develop software. If AI lived up to the hype, you'd expect my contributions in the last year to have gone up significantly. As it is, they've only gone up by about 25%. That's about in line with the findings from this paper, The Effects of Generative AI on High-Skilled Work, where they analysed software developer productivity. And their finding was a 26% increase in completed tasks amongst developers using the AI tool. Some studies have even shown LLMs actively hampering productivity. That's not my experience, but I think it's good to stay skeptical. But for me, the bigger thing is it's not only about speed, but also mental effort. I find now that I don't have to type in every single line, and I can use the LLM to help with research tasks, refactoring, writing tests, and using technologies that I was previously less familiar with. The required amount of effort to build a piece of software has definitely gone down, and I face larger software tasks with more energy than I used to. I'm also able to reach further into domains which I previously wouldn't have, because the learning burden was too high. In working with LLMs, I've found that context is everything. You get much better outcomes if you give the AI good context about what it's working on. So context includes your own code, any libraries and APIs you're using, any example codes such as curl requests to APIs, any higher-level software specification describing how you want things to work. Similarly, architecture documentation can be useful, describing which pieces of technology you want to use and how you want them to hook together. Algorithms, data structures, file formats, things like that. And finally, I've found it useful to provide high-level instructions on how I want the LLM to code. So what my tastes are, things like functional versus object-oriented programming, how to comment, what to do when refactoring. So why include context? If you think about it, the LLM has an imperfect copy of many libraries. Popular libraries go into its training set, and things like Three.js will be quite well known. That said, it is an imperfect copy. It's compressed in a lossy way, and it won't contain all the information the LLM needs to use. So how do you achieve this? So I've created a basic front-end project here. Now, usually what I do is I make a directory called context, and then I CD into that while I'm planning the project and think about what kinds of things is the LLM going to need to know about. And then I actually just symlink from my AI contexts folder, and I've got a bunch of different files in there for different things. So because I'm doing a ClojureScript project, I'll symlink to cljs.markdown. And if we take a look at that file, you can see that it's just basic ClojureScript guidance. It's quite short, this one. So then I'm going to link to other documentation that I might need. And something that I quite often do is link directly to the README of a project I'm going to use. Some projects have great quick start documentation, and that can be really useful for the LLM to get up and running. So an example would be if I'm using the Nostr Tools library here, I can link directly to the Nostr Tools README. And actually, normally I'll name that Nostr tools.md. So there you go. You can see I've added these 3 files. I'm just going to symlink a couple more here. So I'm using Ada, and the way that I tell Ada about these symlinks is I have a config fragment. So I'll open my ada.conf here. And so this line of the context tells Ada how to load the context in. And I've got this line in the current folder .context/*. So basically, when I launch Ada, it will always open .context and load in all the files. Now, unfortunately, this is a forked version of Ada because Ada doesn't support wildcards in this read pattern. But hopefully that PR will get merged, and anyone will be able to do these wildcard includes. I'll link to my fork below if you want to check that out. One thing you can do if you have a verbose piece of documentation is ask the LLM to summarize it into a markdown appropriate for an LLM to use when developing with that library. So for example, here if I say /read and then the name of this library, Specisynth Soundbank, which I know has a lot of stuff in there. So we've got all these markdown files. So I'm going to read those in, and then I'm going to say, please create .context/specisynth.md, summarizing the Specisynth Soundbank library. Include all relevant technical details and pay particular attention to code examples. Make the summary concise and useful for an LLM writing code that uses the library. So I can ask Ada to go away and do this. It sends a request off to Gemini. Now, the other major piece of context is this first file here, which is an agents.md. I'm going to link to this repository in this file because this has sort of like high-level senior dev advice for the LLM on how I want it to code. So let's take a quick look at this file. So I've got a bunch of different sections in here, like general development conventions. The LLMs are a bit too enthusiastic about making changes unrelated to what I want them to do. So a lot of this is about confining the LLM to really just edit what I've asked it to edit. Never make changes the user hasn't asked for without checking. Don't try to do too many things at once. tests, build functionality in small steps, testing in between, things like that. The second section I have here is on debugging. I find the LLMs are again too enthusiastic to just issue a fix, assuming they know everything just from the code. Of course, real programmers don't do this. We test out ideas. We come up with a hypothesis. So to confirm a hypothesis about a bug, always insert debugging statements. So I want the LLM to put in some print statements, and then I'll paste back the results of those. The other thing I found is some LLMs are too enthusiastic about removing stuff and cleaning up. I don't want them to remove the debugging statements, so I want to put them in a logging function or something like that. Some LLMs I notice have a bad habit of adding comments saying what they did to the line, which is not really a useful comment. A useful comment describes what the code does, not why you changed a particular line. I've asked the LLM not to do certain things, like often they'll tell me how to run the server, and I've already got the server running, so I don't really want them to do that. And then some bugs I've noticed where LLMs are particularly prone to certain types of bugs, and problems, this one's funny, avoid the string data with a colon directly after it. So that is a problem in Ada because it seems to treat that string specially, and then it mucks everything up. So I've asked the LLMs not to do that. And so that's my main context file that pretty much goes into every project. I don't have to manually symlink that one. As you can see from my Ada config, it reads that one every time. And I'll link to that repo with my agents.md so you can use it yourself if you like. And so I guess the summary with these symlink context files is you can link readmes from tools that you're using and any other relevant documentation you think will help the LLM in the process of building the software. Just remember that it has an imperfect copy of many technologies, and if you provided a better copy, that can help it do a better job. So I highly recommend this technique of symlinking markdown folders into a context directory. So now let's talk about models and how to choose which models to use and when. These days, a lot of people are using Claude Code, which obviously is hard-coded to Anthropic's own models. And those are quite expensive, to be honest. I read a blog post yesterday by a senior developer who was spending $1,500 to $2,000 a month on LLM requests using Claude Code. By contrast, my own spending this month was $133, and you can see the various models I used here. The majority of my money at the moment is going to Google's Gemini 2.5 Pro, and that's what most of my spending was on. You can see I made a total of 1,638 requests, so those would be individual prompts going out to the LLMs, and I sent and received 68 million tokens to the LLMs. In order to be able to switch between these different models, I'm using a service called OpenRouter. There are a few of these different services that let you switch between models easily. They act as a kind of proxy layer. I also like that I don't have to directly connect to OpenAI and other large corporations with my own API key that they can use to identify every request. So because my requests are proxied, there's a small layer of indirection, and maybe that makes it slightly harder for them to correlate my requests with me personally. So as you can see, OpenRouter supports a wide variety of different models for software development. And it has this handy rankings page which shows you what people are using at the moment. And you can do comparisons here. And one of the reasons I'm using Gemini 2.5 Pro is it's about 1/3 the cost of the Anthropic models. And I found the effectiveness of programming for the way I use it is about the same. I get similar results from Gemini Pro to Sonnet 4. And just taking a look at this Grok Code Fast model, which seems to be coming up the rankings, I'll probably start testing this one out just because it's incredibly cheap. One advantage that Gemini still has, though, is the context size is enormous. And for some tasks like exploring large amounts of documentation, I've found that big context size can be incredibly useful. It looks like the Grok Code Fast context size is only 256K, which is probably more than enough for most programming tasks. In general, I'm finding I don't want to send sort of more than like 75,000 tokens when making a request, including all the context I was talking about in the last section. So let's say I want to test out Grok Code Fast on my project. We'll go to the model page for that, and we'll just copy the model name here. So XAI Grok Code Fast 1. I've got that on my clipboard, and then I'm going to edit my Ada config. And you can see here I've got a bunch of commented out models that I use frequently, and I'm actually just going to add that one. So model, prefix it with OpenRouter, and then paste it in there. And so if I save that now, let's start up Ada, and you can see it's now using the Grok Code Fast model. So let's give it a quick little test prompt here. Please create a simple one-page app that plays a plonk sound with web audio when you click a button. And you can see it thinking here and just jumping straight into outputting the code. And that cost 0.0025 cents. And so that's how you can quickly, easily switch between models and try different models out. I'll probably take that Grok model for a spin and see how it works. So when using different models and considering context size, etc., there are a few useful commands you can use in Ada. I quite often use the tokens command, and that shows you sort of like how big your chat history is. It shows you these files you've loaded into context, how big they are in terms of tokens, and gives you a total tokens count. So often I'm sending requests that are sort of 50,000 tokens if it's a complicated change that I want with many different pieces of technology in use. And it usefully also tells you how much that's going to cost to send. If we switch the model to, say, Claude Opus 4, and then run that same tokens count, you can see that's order of magnitudes more expensive to send this request to Opus 4 than it is to XAI's Grok. And so that tokens count's a really useful way to monitor what your spending might be and how big your context window is. It also seems to be the case that you can give the LLM too much context. So generally you want to compress things down and make sure you're managing what you send to the LLM so it doesn't get too confused. To do that, you can use the read and drop commands. So let's say I want to drop this Promesa library here. I can just say drop and it removes it from the context. And if I want to read it again, I can add it back to the context as a read-only file. So you'll note here it says read-only files, these ones are in context, and editable is index.html. And so that provides a fairly easy way to try different models and manage the context that you're sending between them with symlinks and these read and drop commands. So now let's take a look at some different techniques you can use to make your LLM usage more effective. So the first tip I'd give you would be to use small iterative prompts. I don't like doing one-shots where the LLM builds the whole thing. It's harder to reason about and it often adds bugs. If you ask for smaller, more iterative things like change this one button to do this one thing, or change the layout of this header to look like this, or even swap out this library to use a different one in its place, or refactor some piece of code into a function, the LLM is much more effective and makes much less errors if you do something small and concise like that. It's good to use Git for checkpointing, so when the LLM fixes something and it works, commit it into Git straight away so you can roll back easily if the LLM screws everything up. Another useful thing you can do is get the LLM to help you write a specification. So we can use a prompt like this. I'm building a web app for making plinky plonk sounds in the browser. It's an entirely client-side app. Help me write a specification. Ask me questions about how the app works, technology choices, etc., until you have a good understanding of the specification, and then write it into .context/spec.md. If we run that, the LLM has asked a whole bunch of questions here. So core functionality, what exactly are the plinky plonk sounds? What should the UI look like? And so basically I can type a bunch of answers to those saying, number one, simple oscillators with envelopes. And so normally you'd go into more detail with these answers and really flesh things out. And sometimes the LLM will go into an iterative loop with you depending on the model. And you can answer the things one by one as it asks them. But I'm just going to send that off and then we'll see what spec.md it comes up with. And it's written a fairly straightforward spec with pretty much the answers I gave, but fleshed out a little bit maybe. And a lot of the value here is really in just the questions that the LLM asks, things you might not think to document yourself. And of course, now that this is in the context as the spec.md, when the LLM's building the app, it'll have something to refer to understand your preferences about the piece of software. And that can be useful even when you're making small changes, because the LLM has some context about what the whole app is supposed to be doing and what we're working towards. And so speaking of working towards something, another thing you can do is to-do list driven development. This is a basic project I was building with an LLM over the last few days. So you can use it to create product shots of different boxes, basically. And so the way I did this was with a simple to-do list. Each time I tested the app, I would write down something that it needed to fix. And basically then in Ada, I would say, take a look at the first to-do list item, explain to me how you'd implement it, and then go ahead and update the code if its implementation plan sounded sensible. And that's another thing I have found, that sometimes I ask the LLM first what it's going to do, so it doesn't just completely botch everything up. And if the plan has issues, I'll tell it, well, tweak this slightly and do it this way instead. Basically guiding the LLM to make better choices. And the result here was pretty good. It's an app in a single index.html file with 39K, and it pretty much does everything I specified. There were quite a few bugs I came across and edge cases that I had to ask the LLM to change, but it did a great job. Incidentally, you can find that app at mccormick.cx/apps/boxshot if you want to check it out. So another technique is to use an LLM to do research for you. Here you can see I was interested in using the sound font 2 specification and how to write percussive instruments into this SF2 format. I used Claude's research feature and it went away and looked up a bunch of links and put together a document at the end, which I could then use to put into the context to give the LLM that I'm coding with references for how to do something. So this was quite a deep technical task and it needed to get it right with actual real world information on how the file format should be structured and things like that. And so yeah, using LLMs beforehand to research different things can be very useful. If we run Ada with the watch files flag, and then open the file, we can add a comment in line like change this to be a snazzier message with this special token AI exclamation mark. And Ada will pick up on that. And as you can see, it's processing the request and it's made the change. And we didn't have to write the prompt into the chat window here. We can just kind of like work from inside the file. That makes prompting faster, and it also tells the AI where in your file to make the edit. And so the final technique I want to show you is a design thing. When building UI, you can prompt with images as a reference and often get quite close to what you're looking for. So if we go to a site like HTML5Up, where they have a bunch of free templates, you can actually just take a screenshot of the bit you want and copy that. Then we go back to Ada and we just paste that in. And then we can write a prompt like this. So I've said, please create a concise single-page HTML file implementing the design in the pasted image. Use minimal vanilla CSS styles. And so then the LLM spends a minute thinking, and now it's produced our final HTML file. Let's see how it looks. We'll load it up in Firefox. And you can see it's done a reasonably good job, but it's quite different to the original. All of the elements are there, but they're aligned differently. So for my second iteration, I've said the alignment doesn't seem to have matched the original, where the elements were aligned to the left-hand side of the page. Please fix it. Once again, it goes off and does a bunch of thinking. And now it's done, it's made that change. Let's take another look. And now it's successfully left aligned it. And so it's not exactly the same, but it's a reasonably good job. You've got the same kind of layout. Now, sometimes I've found that it'll do a much better job and get much closer to the original image. In this case, it hasn't really, but I think it's important to be honest about the capabilities of LLMs. For 2 prompts that cost 8 cents, I think that's a pretty good outcome. I could take that index.html and iterate on it and use it from there. Prompting with images I've found is highly effective, especially if you've got some complex piece of UI and you don't want to write all the styles to lay it out yourself. So those are my senior dev LLM techniques for more effective software development. Hopefully that's been useful for you, and thanks for watching.